Today we're working on part B of 1.3, and this is going over one, no, or infinite solutions. So yesterday and every day previous in chapter 1, we've been working on one solution problems. So now I'm going to introduce no or infinite solutions. So if you think back, whenever we had a one solution, we always ended up with x equals. So what happens when we lose our x or get something else that doesn't really work? That's when we get no or infinite solutions. So let's do a quick review and just a quick warm up over these two problems. So go ahead, pause the screen, solve for x. This is just going to be a quick refresher over what we did yesterday. For the first equation, you should have gotten x equals 10. Second equation was a little bit more difficult, but you should have gotten x equals 5 at the end of that one. So both of those have one solution because we got x equals a number. So at the end, you should have x equals some number. So both these are considered one solution because x can only equal that one thing. So let's try this problem. We're going to start it off the exact same way that we would have before. So I'm drawing my line, and then I can see on this left side that I can combine these two numbers there. So I've got 3x and then negative 2 minus 6 if I put that in my calculator, or KCO it and see negative 2 plus negative 6, I get a negative or a minus 8. And then we didn't do anything to the right side, so we're just going to keep it. Next thing I'm going to have to do is combine my variables. So I've got a variable on the left and a variable on the right. So let's move this one over to the other side. It's a positive 3x. So I'm going to do a minus 3x to both sides of my equation. Positive 3 minus negative 3 gets rid of that, leaves me with a 0. So technically what I'm looking at is negative 8 plus 0, but we are smart 8th graders. We know that negative 8 plus 0 or anything plus 0 is just going to be itself. And so we can just leave it at that negative 8. On this left side, we've got a positive 3 minus 3. That actually gets rid of it on that side too. So the only thing that we're left with is a negative 8. Now I don't have any variable at all. But I do have that negative 8 equals negative 8. I know that's a true statement, so what does that mean for me? So when you lose your variable, and one side is the same number as the other side, so what we have right here, we can say that it has infinitely many solutions because any number I put on that for x is going to work. So it has infinitely many. Infinitely means a ton, so big that you can't even count. And so literally any number that I put in for x, it's going to work out because it's the exact same thing on both sides of the equation. So if you look when we combined those like terms, we had 3x minus 8, and then on that right side we had negative 8 plus 3x. If we're looking at our x variable, it is a positive 3 in front of the x, a positive 3 in front of the x. And then that little extra number is a negative 8 or a negative 8. So since it's the exact same thing on both sides, it's going to have infinitely many solutions. To identify if you have infinitely many solutions or in the future no solutions, what you're looking for is that number in front of your variable. So I'm looking at 3x and I'm looking at 3x. Since it's the same number, that same coefficient, the number out front, I know that it's either going to have infinitely many or no solutions. I know that it cannot be a one solution because I'm going to eliminate them. They're going to go away. And so let's look at the second problem to see what that no solution looks like. Just keep in mind that infinitely many has negative 8 equals negative 8. the same number on both sides. So I guess you can kind of predict what no solutions are going to look like if you know that infinitely many is the same number on both sides. So let's try that problem out. So we're looking at this problem here. I already know that it's going to be either infinitely many or no solution. I know that because that number in front of my variable is a positive 4 on the right and a positive 4 on the left. Let's go through and solve it to see if it's going to be infinitely many or no solution. So there's no distribution or combining like terms that I need to do, so I'm just going to subtract 4x on both sides of my equation. And like we predicted, it eliminates those two. So we're left with a negative 18 on the left and then a positive 5 on the right. You have to ask yourself, does the left side equal the right side? Does negative 18 equal positive 5? And you should tell me no, it does not. So since negative 18 doesn't equal positive 5, I know that I have no solution. So when you lose your variable, we lost our variable, it's not there anymore. And one side is a different number than the other side. So that left side does not equal that right side. It's going to have no solution. And so for both of these problems, so this one here and that previous one we were working on that had infinitely many solutions, that's going to be your answer. Instead of saying x equals 5 or x equals negative 3, this one's answer is no solution. The last one's answer was infinitely many solutions. And so that's what you're going to be writing on your answer line because that is the answer. So you can have one solution, which you would write x equals 5 or x equals negative 3, whatever x equals for infinitely many solutions. That's going to be your answer for that one. But this problem here has infinitely many solutions, so that's going to be our answer, infinitely many solutions. This one has no solutions, so our answer is no solution. So now you've got two problems to work on your own. Tell me if it has one solution. If it has one solution, tell me what x equals. Or tell me it has no or infinitely many solutions. So pause the screen now, work through these problems, and see which one of those three it is. So once you combine like terms, you should have seen that you had a negative x on the left and a negative x on the right, which eliminates both of them. When you combine like terms on that right side, you get a positive 16. So once you eliminate your variables, you get 15 equals 16. Well, 15 does not equal 16, so it's going to be a no solution. On this right side, we can see that the left and the right side are both simplified. And I know right off the bat that it's going to have at least one solution because there is different numbers in front of our variables. So this one has a negative 5 and that one has a positive 1. So once I go through all those steps, I should find out that x equals negative 7. So just as a quick review, if you have one solution, your answer should be like x equals 4 at the end. If you have infinitely many solutions is your final answer. That is what you're writing on the line. But when you see it, it should be 24 equals 24, 12 equals 12, negative 7 equals negative 7, whatever it is. The left side is the same as the right side. But your answer is infinitely many solutions. Whereas if you have one solution, your answer is x equals 4. No solutions, same thing as infinitely many solutions. That is your answer, is no solutions. That's what you're circling. But when you go through and solve the problem, you know it's a no solution because you get something like 5 equals 2. So those two numbers do not match up, so you know that it's going to be a no solution. And so the last thing left is to talk about our homework. So that is going to be a passed out page, quote unquote. Look on Canvas for that. So when I go into Canvas, I am on this page. Click here to view your homework. what you're doing is after you read those directions, you should know that you're identifying if it has one solution, no solution, or infinitely many solutions. And if it does have a single answer or one solution, you should have x equals whatever number it is. And it says it right up here in these directions, what you should be looking for. And then there's going to be 6 of each type of problem. So there's going to be 6 one solutions, 6 no solutions, and 6 infinitely many solutions. So you've got 18 problems to work through and tell me what kind of a solution it has. If you have any questions, please email me.